Hey everyone, thanks for coming. Welcome to Best Practices for Performing Custom Code Transformations with Agentic AI. My name is Morgan Lunt. I'm a Senior Product Manager on the AWS Transform team, and I'm here with Venu.
Hey, I'm Venu Vasudevan. I'm a Senior Specialist Solutions Architect with the Next Gen Developer Experience team.
This would be helpful. So what we're going to talk about today is the challenge of technical debt, which I'm sure you're all very familiar with. I'm not going to spend too much time on that. Some scaled remediation options, things that you may be aware of, and some things that you may be new to you. Some best practices that we've discovered internally in AWS when managing tech debt at significant scale. And then the thing you're all here for is the live code demo, where we'll actually show you the tools that we use. So the problem with tech debt. It's big, it costs a lot of money, it takes a lot of time, it slows down your innovation. It prevents you from being able to deliver new features to customers. It prevents you from being able to hire developers that really understand your stack and can contribute to it properly. And it may bring security vulnerabilities and all sorts of bad things. So generally speaking, tech debt bad. Different kinds of technical debt. You can have security and compliance risks, especially if you're in a compliance-oriented industry like healthcare or finance. But even for any company, a security vulnerability can cause massive PR issues, monetary loss, all sorts of things that you probably don't want to happen. Maintenance burden. Sometimes it can get to a point where feels like you're doing patching and addressing vulnerabilities and CVEs, and you're not actually spending time developing things that your customers want. Performance limitations, so your things can get slow, they can get crufty. You can have large applications built up over 10, 20, 30, 40 years that when they were initially built were well designed, but after caking mud on the ball for many, many years, it becomes unwieldy. And this can also cost you money in terms of being more expensive to run on bigger VMs. And finally, strategic misalignment. So a lot of customers that I've spoken with work at companies that were acquired by other companies. And companies that are acquired by other companies may use a different tech stack than the rest of the companies in the portfolio. So there's often a desire within corporations to have some sort of standardization and internal alignment for the tech stacks they use, the libraries they use, the APIs they use, the vendors they use, which are going to have their own different APIs, and all that fun stuff. So these are some customers that I've worked with pretty closely over this last year. Air Canada has a big issue with thousands and thousands, I think tens of thousands of Lambda functions running on deprecated versions of Node and deprecated versions of Python. And due to compliance and internal standards, they desperately need to upgrade these. And it takes a lot of time and a lot of manpower to go through every single Lambda individually and try to upgrade it to the latest version of Node or Python. Twitch, our friends inside of Amazon, have a lot of Golang code. They're kind of unique in Amazon. Not a lot of people use Go, but Twitch does. And a lot of it's written using AWS SDK v1. They want to migrate to AWS SDK v2. They have over 900 applications. I think they projected originally 11 developer years of manual effort to do that. QAD is a major ERP vendor. They make software for manufacturers that make products that we all probably use. They have a piece of software that's evolved over 20 plus years, and their customers have built customizations on top of this ERP software to do things particular to that customer. Super useful if you're a customer and want to augment this off-the-shelf ERP with your own functionality, but over time, this builds up cruft and makes it very challenging for QAD, for the vendor themselves, to publish new versions of their ERP, because everyone's got kind of a one-off special little thing. And so they have this challenge of moving these customer-done customizations onto their common customization framework on their newer platform versions. And then MongoDB. They and their customers have a lot of Java code. A lot of this Java code is on Java 8, Java 11. They really want to get it up to Java 21 or later versions, and that's easier said than done. So there's a lot of existing approaches for doing code modernization at scale in an automated fashion. There's good old rule-based automation. So this is stuff like AST grep, managing abstract syntax trees, using something like Open Rewrite. And these are good tools if you can get them to do what you want. They'll do it deterministically and they'll do it reliably, but they can be kind of brittle and kind of inflexible. If you introduce a new piece of code that isn't exactly following the same conventions as the ones that you wrote your transformation recipe with, it's probably not going to work. And it takes kind of some specialized expertise to write these sorts of recipes. You have to know how to navigate an abstract syntax tree. You're kind of like writing code to manipulate code and dealing in this kind of conceptual higher level. And it's a little tricky if you haven't done it before. And because of that, there's a bit of a higher startup cost in using approaches like that. General purpose coding AI has gotten really good. The Kiros and the Claude Codes of the world are awesome. You should all use them. I love them. I use them a lot. But one tricky part about doing large-scale code modernization efforts with them is that there's no easy way right now to enforce consistency across a bunch of developers trying to do the same task using those same tools. I might ask a Kiro to do upgrade a Java runtime, and it'll probably do it, but it may follow different conventions and different patterns than a Venue does it. And we're going to end up with disparate code that may not follow the standards and use the right libraries that my organization wants to use. These tools tend to be designed to be run with a human in the loop, with a human sitting at the keyboard, driving it, watching what the agent does, poking it this direction or that, which again, fantastic if you're doing something once, not so fantastic if you're doing it 100 times, 1,000 times. That human cost, even though it's a significant acceleration from someone sitting out and doing this work themselves with no assistance, is still real. There's still significant cost to clicky-clacky driving a coding agent on a keyboard. And another issue with doing it this way is that teams' learnings remain siloed. So if over the course of an API migration you discover, oh, there's an incompatibility between these two particular versions, I had to do this workaround, you learn that, you discover that, but some other team, on the other side of the country, on the other side of the world that's doing the same migration in your organization, they're going to go have to discover that themselves. They're going to run into the same issue, and unless you're really good about updating wikis and looking at those wikis, that learning is lost. Like that you're going to run into the same problem several times, and that's not as efficient as can be. So what do we need? We need a code transformation, the scalable code transformation mechanism that has a low barrier to entry. It's easy to get started with, doesn't take a lot of specialized knowledge. It's designed for automation. It can be scripted together and just kind of set up to run in a headless, without human interaction fashion. Something that you can teach once and you can run it everywhere. And that gets better every time. So you don't lose these learnings that individual developers are coming across. Enter AWS Transform Custom. This is my baby. I'm the PM on this product. We've been working on it for the last year. This was released GA on Monday. We're all very excited and proud of it, and that's what we're going to be showing you in a minute. So AWS Transform Custom is intended to learn from you any sort of code pattern, API upgrade, runtime upgrade, framework upgrade. I have people doing things as wild as converting VBA script embedded in an Excel spreadsheet to maintainable Python code, and it's working okay for that. Or rewriting bash scripts to Rye, which is a Rust-based scripting language. Like the more I learn about how customers are using this, the more scared I become, because there is some weird stuff out there. Because you can teach it your own custom code transformation, you can do your weird stuff with it, which is cool. And because you are teaching the agent, if it's doing it wrong, you can tell it to do it different and to do it better until it does do the right thing, and it does it consistently enough that you feel comfortable to start running it at scale. It continuously learns, it gets better every time. We'll show you how that works in a moment. And it's easy to run at scale. So the main components of AWS Transform Custom is our CLI that you'll see in a moment, which you interact with using natural language. So you tell it, hey, I want to blah the blah from blah to blah. And it's going to say, okay, cool. What the heck is a blah? Do you have some documentation on blah? How do I go from blah to blah? And we've encoded all these best practices that we've discovered internally at AWS for doing scaled code modernization into the agent. So it's going to know the right kinds of questions to ask you. If you say, I want to do an API upgrade, it's going to say, cool, do you have the swaggers? Do you have the API documentation? If you say you want to add a whole bunch of test cases, it's going to say, okay, can you give me an example of like the kinds of style you like your test cases to be written in? Or if you wanted to emit metrics in a different way, it'll ask you for the schema. So it shouldn't take like a whole lot of domain expertise to build this transformation that you're going to want to apply at scale. Once you've built something that you're comfortable with, you're pretty happy with the performance, you've tested it on a few repos, executing it at scale is really straightforward because it is a CLI. It's a CLI that can be driven by a human talking to an agent like you're all used to doing these days, I imagine, or it can be driven by a machine. So our syntax is totally deterministic and machine drivable. You put a bunch of commands, a bunch of arguments in the command telling it, run this transformation on this repo, following these conditions and blah, blah, blah. and it'll just do it. So it's really easy to write a shell script to pull down your code from wherever it is, GitLab, GitHub, Bitbucket, I don't know, what other places do? And transform it and push it where it needs to go. Send it for code review, send it straight to prod. I probably wouldn't recommend that, but you do you. Continual learning, both during execution of a transformation, an agent is just going to record notes about what it encountered. So if it goes down like a really deep self-debug path, trying to deal with some weird incompatibility it discovered during execution, and then it had to backtrack and try something else, it's going to remember that next time and try the shorter path. Likewise, if you do an interactive transformation, sitting there and watching the agent, which is an option you can do, and you see it going off the rails, you can tell it, hey, don't do that, do this. It'll remember that and hopefully not do it next time. So how does the process work? The first thing you do is you have some sort of expert. They could be on a centralized team. They can be someone that owns a particular service that a lot of other teams are consuming, someone who kind of knows what they're doing about this transformation. They're going to sit down with our agent, and they're going to describe what they want to do and go through that transformation definition building phase. A transformation definition is this term we invented to represent the agent's understanding of a particular transformation. So it's a combination of some markdown files, a RAG, and a database of learnings that the agent's encountered during its executions. And this is something that we consider to be your IP. We don't look at it. We don't learn from it. If you want to sell it, if you want to keep it secret, if you want to open source it, that's none of my business. The transformation that you build is yours. So someone's going to create an initial transformation definition. They're going to execute it a few times on some local repos, and they're going to look at the output, and they're going to tell the agent, you screwed this up, you missed this edge case, you should do this differently, and it's going to update that transformation definition, and then you run it again, and then you run it again. And hopefully, after 3 or 4 times, and not 30 or 40 times, it's starting to get to the point where you're like, okay, this is like doing what I want for the most part, cool. At that point, you're ready to share your transformation. So we make that really easy because we have this notion of a transformation definition registry, which is just something within an AWS account. If you give someone the right IAM permissions, and the transformation definition is just it's an honorable AWS resource. We're not reinventing the wheel here with permissioning and resources. It's the concepts you already know and you're used to. You can make the transformation definition available to other users in your organization. They can pull it down, they can execute it on their code, they can propose changes back to it, and everybody is happy. And once you have the application owning teams somewhat happy with the quality, you can start running it at scale. And you can do that in the form of a push campaign, if you like, where some central team pulls down a whole bunch of code from a whole bunch of teams, executes a transformation, and sends the resultant code out to be reviewed by the application owning team. Or you can do it pull campaign style, where you tell the application teams, hey, you must blah the blah. You know, there's a top-down mandate that you must blah the blah. But I'm going to give you this thing. You could try running it. Hopefully it does most of the job for you and makes your life a little easier. And humans verify. And the continual learning goes back into the transformation definition. Super cool, right? We have been eating our own dog food, as we do at Amazon. We've built a whole bunch of transformations that we thought were useful using this, and we have done some pretty comprehensive benchmarking on them using internal AWS code and some open source code. And so we have this little menu of transformations here, notably Java, Python, and Node runtime version upgrades, AWS SDK version upgrades for those languages as well, that we are confident in, that I'm putting my name on, that we believe are pretty good, and we give to you, and you can just run them. You don't have to create a new transformation at all. If you're trying to do Java, Python, or Node runtime upgrades, or AWS SDK upgrades, just use these, and they should get you most of the way there. And if they don't, tell me, and I need to fix it. Beyond that, we have a couple of early access things that we've also released. So a tech debt analysis / documentation transformation. This one's pretty cool. It'll go through all of your code if you've got something really old and poorly documented and generate what Venu and I think is like a pretty comprehensive documentation set of it, including entity relationships, sequence diagrams, lots of pretty images, full dependency trees and stuff. Like it's like every way you could think of to represent code without having the code itself, we try to capture in here. And as a bonus, it gives you a little report in there that says, hey, you're using a super outdated version of this and that and this is vulnerable, and like you might want to check these things out. And then we also have an upgrade that we're working on with the Graviton team in AWS to convert Java code that uses x86, that has dependencies on x86 libraries, to Graviton. That's early access, doing pretty well in benchmarks. We'll probably mainline that one pretty soon. These are no setup for you. They're validated by us. We have a pretty comprehensive benchmarking infrastructure to try to get the quality on these really good. Beyond that, you can build custom things. You can build VBA to Python. You can build, something crazy and unholy if you really want to. I would recommend using it for API upgrades, language version upgrades. You can use it for language-to-language conversions, but I would caveat, like, in a localized context. If you have like a 500,000 million line of code old .NET app and you want to re-implement it in Java, you're probably not going to have a great time. The models aren't quite that good yet. But if you've got like a whole bunch of scripts that you want to convert from one language to another that are relatively self-contained, it'll work pretty well for something like that. Best practices, because that's what we're here for. That's like the title of this thing, I think. Pilots. Start building a transformation. It's not very hard, and then just run it on a few things at small scale. And that's how you get a feel for the efficacy. That's how you get a feel for what it's going to cost. So pricing for this is entirely usage-based. It's based on agent minutes, which is just kind of an abstraction on top of our cost for providing the service. It's 0.035 cents per agent minute. A typical 1,000-line Lambda costs about $1. I think a 5,000-line Java runtime upgrade costs like $4 or $5. We really intentionally priced this thing very low to make it up on scale. So we want to incentivize y'all to create transformations that do what you want to do and unleash them and just build a lot of scale. Plan, refine, pilot. I think you all get the picture there. And another best practice is use your current workflow. There's a lot of code transformation products out there that I've seen that kind of ask you to onboard to a totally new way of doing things, and I think that's lame. So we've intentionally built this to be a CLI that has very minimal dependencies. It has a dependency on Node, a dependency on Git, and a dependency to have an external connection to our service, to our AWS servers. If you have a machine that has a Linux environment, macOS also works, WSL also works. Benny's going to demo this on WSL. Has those dependencies, you can run your transformation. So people stick it in pipelines, people stick it in Docker containers, people stick it in AWS batch jobs, people stick it on laptops in their basement. Like, I don't care how you run it. Whatever works with your current way of doing code modernization and doing deployments and stuff, it's designed to be minimal and just slot in. And I would be remiss if I did not plug our AWS Transform web application. So if you heard about AWS Transform last year, this is all there was to it. We didn't have the CLI. The CLI and custom is the brand new thing this year. But there is integration between the CLI and the web app. So if you are a program manager, a campaign manager, you're responsible for doing a bunch of code transformation at scale, and you want a place to get pretty charts and graphs to show your boss and stuff, all of the status of the campaign that you're running in the CLI is automatically populated in the AWS Transform web app, where you have pretty charts, pretty graphs. You can see what repos have been transformed, which ones have been validated. And of course, you've got the agentic chat there, so you can ask questions about the data. You can say what proportion of them fit these criteria, how many got done in the last week, which ones had failures, whatever you want to ask it. All right, now the fun part.
Cool. Yeah, thank you so much, Morgan. I have a question for you before I get started.
Yeah.
Customer asked, can I do Fortran to Python? What's your answer for that?
How big is your Fortran? That's the question, right? If you have you can do hello world, any language to any language, and beyond that, the complexity, it varies. I don't want to overpromise to anybody. We have a customer using some weird esoteric old language called Progress that I had never heard of before, that we didn't know if the model was even going to understand, and it totally groks it, and they're putting 100,000 line of code repos in there effectively and making changes. So again, I said best practice pilot before. Just try it. It's cheap and easy to start and try. We made the installation as easy as possible. It's one curl command to pull down our CLI and start trying it out.
Cool, thanks. Thanks for that. Okay, let's now do some coding, live coding, right? So the way that I've set up is, so Morgan talked about the built-in transformations as well as the custom transformation and doing it at scale. So let's see if we can do all of them, right? So let's start with the out-of-the-box transformations and let's see how it works, right? So the first thing is, this is a command line interface, CLI. You can install it on your laptop. So I'm going to use a WSL environment on Windows. Mac and Linux is supported. So I've already installed it. And I'm just going to start with my first command. So like Morgan mentioned, this can be run as an interactive mode as well as non-interactive mode. Non-interactive is basically a bunch of commands. You say, hey, ATX, run my transformation on these repo, it'll just go do it for you. Or you can interact with this, give some feedback, and do it interactively as well. So we'll show both of these modes right now. So first thing, I'm going to list, it says, hey, ATX custom, that's AWS Transform Custom, definitions list, okay? List all my definitions, right? Okay, so I have a bunch which I have built. But let's go through the AWS managed ones, right? So we have 8 AWS managed transformation, which are out of the box. 0 setup, you can just get started. The AWS SDK V1 to V2, Node.js, Python upgrades, Boto 2 to Boto 3, Python version upgrades, Lambdas and non-Lambdas as well. Same thing with Node.js. In early access, we have the comprehensive code base analysis, which Morgan talked about, and Java version upgrade. Again, it supports Maven, Gradle, build systems, and x86 to Graviton. And these are some of the user transformation that I built for demoing to customers and for my personal use as well. And this is the registry that you see. So it's basically published to the registry. So once you publish it, any user in your AWS account who has access to this CLI and proper IAM permission should be able to view it, just download it, and run with their project.
You're better than me. When I demo it, I just use the AWS internal registry, and it shows like 350 transformations, which is good. A lot of people internally are using it.
Yeah, so awesome. So let's start with the first one, right? So I have a Lambda function here. It's basically a to-do application. So let's start by running this transformation on this Lambda function, right? And this is the command that I'm going to use, right? Let's put this and then probably explain what exactly I'm going to do, right? So this use case is basically, hey, you're just going to use out of the box. You know what you're doing. You have a bunch of Lambda function, go run it, right? Again, 0 setup, just go run it without creating your own transformation, right? So I'm going to say, hey, ATX custom exec is execute, and this is -p is where is my Lambda function located?
The file path on local disk.
Yeah, local disk, and -n is the Python version upgrade that you saw from the out of the box list. C is, the build command that needs to be used. So in case of this Python, I'm just going to use no operations. But for Java, you'd use, hey, mvn clean install or something like that, right? And the configuration is basically additional context that you could give, right? That's the basically what validation command I need to use, right? Hey, you can say, hey, I'm going to just run PyTest to make sure all unit tests pass. And you can also give, it's basically free form, you can give additional context here of running this execution, right? And I'm going to say, hey, since this is very generic, it can go from any Python version to any Python version. So I'm going to say, hey, go to Python 3.3. -x is basically non-interactive, which means, hey, go run it. And then -t is trust all tools. So in case of interactive mode, you might need to trust tools to write files, read files, all those things. So I'm going to say, hey, trust all my tools, go and execute that, okay? So let's execute this. All right, so it started the transformation right now. Okay. Let's see what it does right now. So basically the first step, it's going to create a conversation log where you can track all the progress and monitor all the progress on the conversation log. And you can resume these conversations as well. Accidentally, your network got disconnected and you control-C'd it. There is a conversation ID. You can just resume this conversation. That's a neat feature because, sometimes things happen, right? Internet breaks down and, you have to reconnect. You can do that here, right? Okay, so let this do this job, right? And I'm going to show you an output, what I did earlier in the day for the same transformation, how it is going to look like, right? So I have a dry run folder here. I just ran the same transformation earlier in the day. So basically it ran and it created the plan, it created completed the changes, and it basically converted my Python function from 3.8 to 3.13. And let's see some of these changes, right? Because this transformation might take anywhere between 10 to 15 minutes. I don't want you to just stare my screen, so
We are working to make it a little quicker, but we figured it's better to be slow and right than fast and wrong. So we optimized for right. Now we're going to optimize for fast.
Yeah. Cool. Yeah. So this is the same project. So it did a 3.8 to 3.13 migration, and so it basically did a runtime upgrade, and datetime was modernized in this new versions, and it also added 17 to 32 passing test cases, and again it documented what it did. It also did improved interpreter performance. And this is all built in. I didn't give any instruction. It is all built in, right? So, and it did not change any business logic. No breaking changes. All those things are, kept. Okay, so it updated the README. These are the files changed. I just did a git diff. So what it does is once it makes the changes, it actually creates a local branch for you and commits all these changes. So which means at any point in time, you can go to the commit ID, roll back, or you can just compare and then review it and then check it in or push your code changes.
It's especially useful if the agent does the right thing for the first 3/4 of the transformation and then goes off the rails, and you're like, I don't want all that work to be wasted. You could just revert to a previous commit.
Okay, so some of these files, it basically changed all the time zone things, and the main Lambda function, it changed a few of the functions, and also requirements.txt, and it also changed the template.yaml. This is I think this is a CloudFormation template I had, so it changed from 3.8 to 3.13 for deployment, and it also it changed deprecated APIs, documentation updates, all those things. So again, just to summarize this, just go run this out-of-the-box transformation if you have a very similar use case for your project, right? So yeah, that's the first thing that I want to show, right? Anything you want to add in out-of-the-box?
No, I think that's good.
Cool. Okay, let's now come to the fun part, where how do you want to create your custom transformation, right? So here I want to show an internal library that our internal team used, the same product, for migrating an internal ticketing system. So we had something called Fluxo, which Amazon's internal ticketing system uses. That's very old, not very hard to maintain. So we wanted to change to something called Tickety. That's also an internal system, but that's more API driven and more performance oriented. So that's why we wanted to change all our projects which uses Fluxo to Tickety library, right? So that's again Java based, but this is very specific to Amazon. Not the large language models does not have pre-trained data on these things. So that's where the power comes in, where you can feed in data or context from your organization to teach the agent how to do this stuff, and then so it can do that migration at scale.
If you've got some weird proprietary library that no one else in the world uses, that's what we're trying to show here.
Yeah. So let's go to this one. Okay, so let's go here. Okay. The other thing I want to also mention here is this connects to MCP servers, which means that you can pull in data pretty much from anything, right? So I have this Fluxo Tickety migration guide, which we have prepared, and then I've just put it into my GitHub repo. It's a private repo. So I'm asking ATX Custom to pull in that information from my internal repositories and then use it as part of your creation of the transformation definition, right? So I'm going to do this in interactive mode. I'm just going to say ATX. That will open an interactive shell where you can interact with it. So I'm going to create a definition based on the migration guide that I have, and then review it, give feedback, then execute the transformation on that.
And the cool thing about this guide, by the way, is if this is that guide I sent you, this is a guide that was written for human users in Amazon, published to a wiki to go and do this work. Like someone already wrote this guide, assuming developers were going to have to do it. So we're just giving that to the agent, no extra effort.
Yeah. So I'm just going to say, hey, create a new transformation. Again, this is the interactive mode. Okay, so it's going to ask you, hey, what do you want to do? Right? Language upgrades, framework migration, library upgrades, all those things. I'm just going to say internal library migration from Fluxo to Ticketing. Again, the large language model does not know what the hell is Fluxo or Ticketing, right? That's where I'm going to give more information, right? First, it searches in the registry, hey, is somebody already created this definition or not? If not, it's going to create a new one, right? Okay, so it's asking me, hey, what kind of application libraries it has? What are the main functionalities? What programming language it uses? Hey, do you have any migration guide, documentation, example code that you can give me that I can learn from it, right? I'm going to just say, okay, hey, refer to this, .md file using my GitHub MCP server. It takes a bit for connecting and getting the right information. It basically started using the MCP tool. Again, I'm trusting this tool.
You can also just give it a local file path to a file.
Yeah, you can download it and give, but I just wanted to show the power of, hey, you can connect to your existing environments. Okay, so, okay. Always fun with a live demo, but yeah, it's doing it. Okay. While this is running, I mean, I think I was talking to one of the customers here. They had a use case for I have a prompt already written using Kiro for increasing my unit test coverage, right? Can I do it on thousands of my repositories? Yeah, absolutely. That's where the power comes in. Hey, you already solved this problem, automation problem once with your existing AI tools. Now you want to expand it or scale it to all other teams. You could definitely do that with creating your own custom transformation.
Another scenario I've heard of from customers that I thought was pretty cool is if you want to make your code AI ready, like you want to write a Claude MD, a Kiro MD file for every repo under your ownership, and you want to follow certain conventions but incorporate aspects of the code there, you can define how you want those agent guide files to look in Transform Custom and have it go just write all of those files for all of your repos.
So one thing is when you have multiple prompts and you need to execute sequentially, one after the other, and one prompt would wait or five, which the other prompt would refer, right? And also it will look at the code. So it's like one prompt will have an output, and then there'll be another prompt which will refer that output as an input, as well as the code base, and shows the material. So it's a sequential execution of multiple prompts. It's kind of a workflow, right?
So it's not exactly a sequential execution of prompts. There's several agents under the hood. There's a planning agent and an orchestration agent and an execution agent. So the first thing it does when you execute a transformation is it's going to look at the transformation definition, which itself has some steps and guidance. It's going to look at the code you're asking it to operate on, and it's going to say, okay, given these instructions and this code, let me develop a plan for doing this execution on this particular piece of code. And it will show that to you if you like, and you can approve it or tell it to make changes. And then it's going to go through those steps. And each of those is kind of sort of like a prompt, but it's not just a single one shot. There's sub-steps in between it, because after each step, the agent is going to call a validation agent. It's going to make sure, hey, does this code still build? Does the action I performed in this step actually fulfill the original intent of this step based on the plan?
Those things are there in the prompt. I have the validation steps part of the prompt. Everything's covered. So do I need to remove it?
I see.
Because that prompt I execute,
So what I would do is I would take that prompt, I would give it to AWS Transform during the transformation creation process and just tell it, here is a prompt I wrote for Kiro to do blah. And it's going to say, cool. Let me look at this prompt, and there should be aspects of it that are directly applicable, and I'm just going to incorporate that into my transformation definition. There's aspects it may ask for your clarification on, but it's going to take that kind of raw information and put it in the structured way that it knows effectively executes transformations with this thing.
That's where the refine part also comes in, where you saw, right? Once it generates, basically converted your prompt into its own, what we call as the definition. That's where you can review it, you can edit it, or you can just give feedback saying that, hey, I really don't like this validation step. Can you add more, right, to this phase? It should be able to accommodate that.
So then it would be, if you have 3 prompts, right, I need to execute sequentially, then it should be 3 transformations.
I mean, that's something you need to experiment, right? First, I would start with one, how it creates it. If that's not what you wanted, maybe split it into multiple parts. If everything can be, contained, yes, multiple prompts. But again, as Morgan told, it's basically a CLI. So you create three transformation, execute this in a batch, should be able to do that as well.
When in doubt, I like to tell people to break down problems as small as possible, as atomically as possible, because you'll get better results there. But for really simple things, you can mash them together, and it'll probably work and might save you a little effort.
Yeah. Okay, cool. It actually created a transformation definition. So let's look at the transformation definition. Okay. Wow, it really is very comprehensive. Okay. So this is the transformation definition that it created, right, for the Fluxo to Tickety migration. So let me, oops. Okay. So it has a clear objective. Hey, migrate code from my deprecated Fluxo ticketing library to modern Tickety SDK. And what is the summary? What exactly it's going to do? What is the entry criteria? Entry criteria is basically, hey, how do you want to take this code in, right? So here it says code imports or uses the Fluxo Java client. That's the entry criteria, right?
Entry criteria is really cool, by the way, because that's how the agent knows, does this transformation apply to this code? So if you point the agent at a whole bunch of random code that does not use Fluxo, it's going to read it a little bit and be like, this doesn't apply, skipping. So in the near future, we'll have an assessment capability where you can point the agent at a whole bunch of code, and it'll tell you before even transforming anything, these transformations apply to this code, and you can kind of stage it out how you want to do it.
And implementation step is basically step-by-step instruction. It basically got information from the migration guide, how to do this transformation. First, hey, step 1, update the build dependencies, and it basically broke it down into these projects. And client initialization, hey, basically how to initialize the new client, and for basically covered for Python, TypeScript, all those things as well, and get ticket operation, all the APIs are also covered, right? So these are the implementation steps, right? This is where you as a domain expert, you can come in and say, hey, it looks good, it doesn't look good, do we want to change it or not? Okay. Okay. The last thing is the validation criteria, right? Yep. So the validation or exit criteria. What is the goal that the agent wants to achieve? How am I going to satisfy? So this is where, again, we need to be very cautious on how do we define this validation criteria. It could be just simple as, hey, my build and unit test pass, right? Or it could be very complex as, so one of the customers is actually doing an Angular to React migration. They actually use a Playwright MCP server to compare visually, hey, my Angular and React, does it look the same? So it could be complex as that, right? So you could, or it could be deploying it to an AWS environment, checking if it works or not. So that's where your expertise comes in. How do you want to validate if this migration is successful or not? All right, so this created a good transformation definition, and as a human in the loop, you can view it, you can modify it based on the feedback, or apply it, or publish to the registry. Okay, so let's apply it first for a sample project. Okay, so now it's asking me, hey, where is your code repository? And I'm going to give this. This is again one of the sample projects that I have, which is in Fluxo, that I want to migrate to Tickety. Okay, so I'm going to say, okay, go ahead with this. Now again, it's going to do the same thing. It's going to go analyze the entry criteria, all the project files, and start the transformation project. So as Morgan described, first it does a planning. So where it plans, hey, how am I going to apply this definition on this current project, right? What are the file changes that needs to be done? Again, here you have an option to modify the plan, give some inputs. Hey, this step does not apply to this project, so skip it, right? You can do those things. And then once the plan is approved, it goes onto the execution mode, okay? So let's see the plan creation. Anything you want to add to the planning or the steps while it plans?
The important thing to know is that it's totally optional to review the plan. You can tell the agent just go for it. It just depends on how hands-on you want to be. That's why, I mean, as we've mentioned before, this thing can run in very human-driven, like you're watching every operation that it does, approving every tool use that it does, watching every file manipulation that it does, and you can always Control-C it and pause it and tell it, don't do that, do this. So if you've got something really complex or a piece of code that you're very sensitive about or whatever, you can watch it every step of the way and very carefully guide it. Or you can YOLO mode it and just tell it, do your best at everything. It depends on how confident you are in the quality of your transformation, how risky this transformation is to you and all that. So you can be anywhere on that spectrum.
Yeah. And the other thing is, during the execution, it also, the validation, right? It validates it. And if there are any errors, it self-debugs the errors and fixes as well, right? We do have a self-debug and validation agent, which does that automatically for you.
And if it can't fix them, we try very hard. So LLMs like to do this fun stuff where they really so badly want to say that they did the job. I mean, we've tried to beat that out of the agent as much as we possibly can. Early iterations of this would delete tests to say all the tests passed, like all sorts of crazy stuff. It's awful. So we've built as many guardrails as we can think of to prevent this sort of behavior and try to enforce some honesty here. So if the agent is like, I did 5 out of 7 steps and I had trouble with these 2 and here's the trouble that I had, like, we really try to make it honest, because if you just go pop this into Claude or something, there's a good chance like everything will look rosy until you dig into it. That's something we've encountered previously.
You guys seem to be very focused on code itself, like language code. We have a challenge with CloudFormation and modernizing the CDK. Mm-hmm. Is that the kind of thing that this tool could do?
There's people doing Terraform to CDK right now with this. The way I think of it is if you've got any structured text and you want to turn it into structured text that looks different, yeah.
You could do that, yeah.
And then you spoke a little bit about deployables, right? So like actually deploying into accounts and validating the deployments worked, being able to really bring in or compare A to B between what was there and what could be there, right?
I mean,
it's all capable. To some degree, right?
It's possible if you build the scaffolding around it, right? Like we're giving you a put in text files and have different text files come out, and you can build the scaffolding around it to deploy it and return to the agent information about validation results and stuff.
With the CLI tool being the sort of mechanism for interaction, so you're scripting around that CLI tool to get it to do the other things that you want it to do, but then turning to that CLI to do the transformations that are necessary.
Exactly, and honestly, like I've seen 2 extensibility approaches taken, and it kind of depends on what's working better for you. So you can wrap our CLI tool in your own stuff, or you can tell our tool to call external shell scripts, external MCP tools, and both approaches work. It just kind of it's what's better for your scenario.
Are the transformations importable, exportable? Can you replicate them to multiple?
Right.
One of my core tenets when we wrote the product requirements for this was that they would be importable and exportable, because as far as I'm concerned, this is your IP. I don't want anything to do with it. Keep it secret, open source it, whatever. That's the customers. They are fully exportable right now, and they are 90% re-importable. And the reason I have that asterisk is because The RAG, the knowledge items that it discovers during execution, rehydrating the RAG database where we store those, is not something that we have gotten around to being able to do on the import side. So you can absolutely export it, and you can mostly re-import it, and we're getting that to 100%.
Can you distribute this around an organization? Like I know you guys were talking about within an account, but I mean, we're running an organization, so could we have a central account where this stuff lives and then be able to distribute that out across the organization?
Cross-account sharing is something that is on our list. It is not there yet. But in the interim, you can export it. Literally, when you export it, it comes out as a zip file with a bunch of stuff, and then re-import it, and you're not going to lose much. And I can talk through what you'll lose and how to get around it.
Yeah.
Can I review the prompt that it generates for the simple like Java 17 transformation? So can I export the prompt and use?
So you can view the plan that it generates for upgrading your code for doing that particular upgrade on your code. The actual transformation definition that we provide you, we had lots of fights with legal about this. We do not share with customers at this time. That may change if I get my way, but we don't share that right now.
But you can extend this. You can extend it with additional plan context and other things, but you can't really view it and modify it right now.
It's a black box that you can tack things on the outside of, and I would like to have it not be a black box that you can modify, but we'll get there.
Okay, so this is the plan it generated. Plan, again, as I told, it's basically how do I apply my definition to this project, right? Hey, first update the build dependencies, then do the client initialization, and what files are going to be changed, what is the validation criteria here, all those things. Again, here, as a human in the loop, you can basically review the plan and provide input. Here I'm going to just say, hey, looks good, proceed. So this will be able to do that. Again, in the interest of time, I'm going to go to my completed one. I'm going to show how exactly it did it and how it created a summary, right? So this is one of the things that I did in the morning. And so this is the migration summary it created. So what has been migrated to Fluxo from Fluxo to Tickety. So the dependencies, this Fluxo Java client has been removed. It added the Tickety client, authentication, client initialization, what it did, what are the changes. Again, get ticket operation before and after code snippet. Basically, it completed all the changes that is required for documentation updates and other things for migrating. So my proprietary internal library to another version or to a different system. Cool. So just quickly going through, I have two more things that I want to quickly show. One is the docs that I talked about. Again, you saw in my in my list, there is a comprehensive documentation analysis. Like I'm just going to do again. So that's basically going through your code documentation, documenting all the code, as well as creating the tech debt, analysis for your code. So this is an early access. So basically it does a deep static analysis of code base and then generating it, right? So I actually did this for one of the projects. I don't know how many of you are familiar with Doom. Doom is a gaming engine that we all love to play, and that's basically I think it's 1990. It was created, and this is pretty much the documentation it had. This is the original documentation. Hey, go use Doom. That's about it. Nothing else, right? So I ran my documentation code base analysis on that, and it actually created this documentation folder, right? Basically, created a complete README, what exactly this code does, what are the quick stats, what is the documentation structure. Basically, it created subcomponents.
One thing I really like is it creates kind of this navigable structure where the markdown files, you can click between them and it'll like navigate through them. It's like kind of a pseudo web page, if you will.
Yep. So, okay, so project overview, it created a project overview. and the file inventory, how many total lines of code, what all things. And from architecture, it basically created a components, what other components are available, and basically created a dependency mapping tree as well. Hey, main program, game systems, core subsystems, and then the utilities. Okay, and what are the patterns this has? Basically analysis, architecture, system overview, and behavior is basically the business logic, like the use cases and behavioral documentation as well, right? What are the weapon properties, weapon mechanics, which is used in the game, decision logic, basically how the decisions are being made in the code, error handling, workflows, what are the workflows. So basically it created all the workflows for me.
Make sure you see the diagrams folder too. I like the pictures.
Okay, I don't know. Okay, maybe it didn't. Oh yeah, okay, maybe it created, yeah. There you go. So this is the component diagram. It has a main engine, main program, game, render, sound, network, play simulation, okay, and abstraction, foundation, external dependencies. Cool. And also the main thing is the technical depth. Okay, so basically it's
some code from 1990. I found a few things.
Security, or rather security vulnerabilities, outdated platform dependencies, of course.
Carmack probably knows better than us, but.
So, okay, 1990 C coding practices. So, yeah. Okay, cool. So, the last one I want to quickly show, I know we have 10 more minutes, is the batch, right? So how do you wrap this CLI into a batch and run it across multiple repositories, right? Again, I used Kiro to create a batch, and then basically an ATX batch launcher. It basically takes the input of a CSV file, which has my GitHub repositories, and I'm going to actually run this documentation on multiple GitHub repositories, and then go run it, right? And you can also provide additional context, what is the transformation name, right? So basically this is the CSV file, and I just wrapped my CLI into a batch script, and I thought let's run this, right? And I'm going to run this script. I'm going to say, hey, launch this batch script with this CSV file in a parallel mode, maximum 10 jobs, it could increase it. And this is the output directory to, this is the clone directory to download the clones from GitHub, and then what is the output directory where you need to, do this. So let's do this. Oops. Okay. Okay, so I'm in a different directory right now. Give me 1 second. Okay, so it's basically checking the version and running these commands here, starting 13 parallel jobs, right? So let's, okay, so it basically downloaded all the, repositories for me, and then started running this, and you can basically monitor the execution logs. It started creating it, and you should be able to see the results. Okay, yeah, so that's the batch mode. Basically wrap up the SEG execution or the ATX execution command, and then go run it.
Our code name was Super Elastic Gumby, so sometimes we slip and say Gumby or SEG. That was really sad. Marketing gave us a real name.
Yeah. The final thing is probably and we talked about knowledge items, so I want to quickly show how the knowledge items look. Okay. So I ran a bunch. So I have created a transformation called Java 21 Modernization for my bunch of Java projects that I had. So I'm going to say, hey, I've run this multiple times on multiple projects. So I'm going to say list KI, which is the knowledge items, which is the continual learning aspect where it learns from the agent execution. Let's see how that looks. So how we have designed this is, by default, it will run with knowledge items, which means it will learn from the execution. That's by default. You can say do not learn as well if you don't want to learn. And these knowledge items, when they are created, they are disabled by default, which means a human in the loop can review it, and if they want to apply it for the next time, they can enable it. So here, if you see some of them, right, like this is a Java 21 transformation, right? Hey, it's found, hey, sealed classes are incompatible with JPA, Hibernate lazy loading, right? And some of them are very specific. Hey, SolarWinds, that's one of the project I ran. It's very project specific. It's not very generic. And again, Spring Boot virtual threads needs this, right? So again, I can go in and enable it. So next time it runs the same transformation, it finds that, it basically applies this knowledge item. So that memory is already there. So, okay, I'll give it to you for a wrap up.
Yeah, thank you for your time. I think that's all we got.